All right, thanks. Yeah, just to catch up, we had a quick introduction already, started recording a bit late, but we were just catching up on like broadly speaking, what the memory team is working on, and also what Andrew's team is working on. And we're trying to figure out like, are we aligned on the goals, and is there any kind of potential for friction there? And I was just like walking through our Q4 epic and what we have done so far, and what I'm working on right now is what we've talked about so far. Yeah, so that's pretty much the gist. So I'm like specifically currently working on putting Sidekiq cluster in front of developers so that if they use the GDK, and there might actually be a couple nuances to this that I might have missed, because there are certain kinds of installations I learned that I didn't know about before, where customers apparently also install GitLab from source. So not via Omnibus, and it is also not a development-driven use case. So I actually need to look at this more and see that I'm not breaking anything. But the core idea is put it in front of developers more, so they just like actually run the code that we also run in production.
I think the primary thing with the source installs, and it's pretty well documented when we were booting Gitly, that was something that kind of caught me by surprise as well, the whole source installs thing. But the number one thing I think is if you can keep the existing method that like a core, the straight Sidekiq start, as long as that carries on working, then that's going to make your life a whole lot easier. If you break it so that running, the old approach to booting Sidekiq in the non-cluster process model, if you can keep backwards compatibility there, your life will be much easier. Support's life will be much easier as well. There'll be far less documentation you need to write, and kind of documentation you need to disseminate to all the people that run source GitLab, right? Yes. And so basically the trick there is just to keep backwards compatibility so that the old approach works.
Yes, that's a really good point. And I think that's the direction I'm going in. I just need to also do more testing in that area. If I'm just to make sure that I'm not breaking anything. But that's kind of how I tried to describe it in the ticket as well. You would basically be running a one process cluster, just to exercise that script, right?
So the other thing that's really worth keeping in mind with regards to that version is, if you can have it that it starts with Sidekiq without any Sidekiq cluster script, that's going to help us with Kubernetes. I can't remember right now whether our Kubernetes Sidekiq runs Sidekiq cluster or not.
Yeah, that's a very good question. That came
up. Sorry, I was just going to say, I think that the general consensus is that there's no need to run a process manager inside a pod, right? Like, let's keep it simple. Obviously there's two things that Sidekiq cluster is doing. One is selecting the queues, which I think we should still have a process for doing that. But running multi-process process hierarchy inside a pod, that's not really something you really, rather keep it simple and let Kubernetes do that for you in that environment. And I'm not saying, I don't even know which way it works at the moment, but I think generally going forward, that is a better, if we can have it that's where we end up in the far future, when everything's just like done in that way. Let the thing that's good at process management effectively do the process management.
Right. No, that's a great point. I think Ben brought this up in one of the issues. I can't.
There's been sort of discussion every now and again about it, but and it's the same. I have sort of the same feeling about the process supervision. On the one hand, I totally agree that like we've got 10 different ways of doing process supervision. Like we've also got Gitly Ruby. I don't know if you know what that is, but it's also doing process supervision. And so on the one hand, it's like it would be great if we could just consolidate all of that and have a single approach. And on the other hand, sort of the place that we're going to, it would be really nice if we didn't have any process supervision at all. And we use the constructs that were available to us through the abstractions that we get from Kubernetes.
That's a really good point. So how far away would you say is that though? Because we also need to make like yeah, we need to think about, how long do we want to, how long is it okay to delay?
So what I would say with that is it kind of like whenever you read that stuff about fusion and it's always 20 years away.
Yeah.
I think Kubernetes, like there's two things, like Kubernetes always seems to be like a little bit further away, but we will be supporting like non-Kubernetes clusters for a very long time.
Right.
Like, not every GitLab instance is going to be running on Kubernetes. Probably ever.
Exactly. And also the development use case is still there, right? Unless we see ourselves running, what is it, Minikube clusters?
Of course, yeah. No, yeah, and that's, I don't know if you've done that much, but I don't find it to be much fun.
Yeah. I have not run like Kubernetes like in a local environment. I've worked with containers a fair bit, but
it's you need to have a pretty beefy computer, and certainly 16 gigs of RAM is like, I found it's really struggling on a machine even with 16
This is
gigs.
another really interesting point. I think that would be too much to explore that in this meeting, but it got me thinking, because we have some very interesting goals on our roadmap, such as GitLab needs to continue to run on a Raspberry Pi, right? So we need to keep this stuff in mind when we make decisions around, we're looking, to like largely deploy under like a very powerful compute environment. Which might be running Kubernetes or being orchestrated by Kubernetes. Like that's not something that will be available on every platform that we will target.
Absolutely, and that's why having like a really solid like process supervisor helps. I mean, obviously the other thing that you should be considering is Jakob Vosma recently moved GDK so that everything's running Runit. I think people call it Runit and not RUnit. But
that's interesting. I always say RUnit. It's called Runit.
I don't know. Like,
it makes sense, right?
I mean, I have no like the tester in me is like it's RUnit because it's like unit testing, but it's not that at all. But maybe Runit. I don't know. But anyway, and for GDK, my personal opinion is that that's been very successful, and it's worked really well as being the substrate. The other thing that's great about it is that Runit or RUnit is what we're using to basically process supervise the whole of the GitLab service, right? And so, is there a case to be had? And I don't know if there's limitations that are preventing this. But in the other places that we are doing process supervision, like multiple Sidekiq instances or Giddily Ruby, can we be doing that with Runit? Like even if we're rewriting the Runit configuration, doing something like, it's not super dynamic. With Giddily Ruby, we know that there should be like 8 or 4 or whatever number of Giddily Ruby processes. And at the moment, that is being supervised by the main Giddily process, which is a little bit dirty, right? Because like Giddily is a Go gRPC, so it doesn't really have any business supervising Ruby processes like that. That's not what
I agree.
But what I'm saying is that you want to be able to say, I want 4 Giddily Ruby processes or 6 or whatever, but it's other than that, it's not super dynamic. And the same with Sidekiq, like you want to have a few. And so maybe for the process supervision part, I know we're kind of veering off track a little bit here, but for the process supervision part, maybe we just kind of standardize on Runit. And there may well be reasons why that's not an option, but I'm not aware of them as of yet.
I totally agree with this. I still think like Sidekiq cluster to some extent already relies on a process supervisor, whether that's Runit or something else. Anyway, because
below it, you're talking.
Totally below it, because like one form of like process supervision or like self-management it does right now is to like kill itself, basically, like kind of send some kind of poison pill as soon as it notices that one of the workers goes away, saying that I shut myself down cleanly and then rely on whatever external supervision process there might be to restart myself, right?
The whole thing,
that's already the case, but there are other other components that perform supervision tasks that are not actually part of that routine. There's, for instance, a Rails initializer that we run, which also looks for like zombie processes coming out of Sidekiq, right? And then we have the memory killer, which runs as a thread. So like I still see there might be value in doing this just purely, even if we move, let's say we move to Kubernetes everything, and that kind of problem solves itself from that perspective. We will have still reduced the number of areas we need to maintain throughout the code base. And instead it will be condensed into a single thing. And if that single thing goes away, then at least we're done. So I'm wondering if there might still be value in doing that as kind of an intermediate step.
Yeah, possibly. I mean, the other thing to kind of keep in mind is that there's two things that Sidekiq cluster is doing. One is kind of configuring Sidekiq according to a bunch of queues effectively, and the other one is basically spawning them. And might also make sense to separate those things, because in a Kubernetes world, you still want to be able to say this pod is going to run this set of workers, but without doing the supervision side. So kind of keeping those as separate concerns that can be combined or run separately, is something else to think about. Yeah,
for sure. Actually, I have like one last question about this, and then maybe we can move onto because I definitely want to talk about the new syntax as well that you introduced. But one last question I have: Do you know if as part of the move to Kubernetes, would that entail like single node customers? Because my understanding is we have a lot of customers that run omnibus installations on a single physical machine, basically. So is the idea then to make this a single node Kubernetes cluster as well, for just to simplify the whole deployment?
No, I mean, like I've never heard of that's not something that I've been involved in any discussions around. And obviously, if your job is to run everything on a Raspberry Pi, and then so sort of like we're saying as a company, we're going to run everything on Kubernetes. That's kind of like making your job a lot harder, right?
Yes.
But at the same time, because obviously you have much less memory to play around with. But at the same time, I know Camille feels quite passionately about breaking things down into smaller services, and I also feel that we have to go that way at some point, to some degree. I'm not talking about 10,000 services, but just breaking things down a little bit more might help kind of structurally in the application.
I'm on board with that. I come from that sort of background, actually.
Yeah. The problem that we have that most companies that are doing that don't have is that we need to run things on the Raspberry Pi.
Yes.
And obviously then we're looking at some sort of process supervision and something for wiring. And the risk, I think, is that you could end up building your own really bad Kubernetes if you don't build it on top of something, right? And so, you might start off by saying, okay, well, we need like process supervision, so we're going to use Run It for that. But okay, now we've got this problem where we don't know what port everything's running on, and so we're going to build like service discovery, and obviously on the one hand you've got the Kubernetes side of things that does all of that for you, and on the other hand maybe an omnibus, you're building all that stuff yourself, and in actual fact, so my only thing is that we have to think it out properly, because maybe there is something that we can use that's like a really lightweight thing that gives us the process, the bare minimum of what we need, which is maybe like some sort of load balancing service type thing, and obviously restarting containers and upgrading them, and a few other things like that, but without really kind of building up. I don't want to go down the not invented here route and kind of building.
No, totally agree.
We've got enough of that. Did you know that we've got our own like database load balancing code built into the application, for example?
So I did not. Is that the PG Bouncer project, or is that?
No, it's actually there's a different component which goes and does lookups against console, and then looks at the ages of the replicas and kind of moves.
I did not know. Yeah.
But sort of my point with that, that's there for historical reasons that were valid at the time. But my point is that we don't want to be building up stuff where we can just be, that's kind of like stuff you can get now, and we don't need to be building that. And so there's, on one hand, like I don't have an answer here, which I wish I did. But on the one hand, we don't want to build all this stuff ourselves. And on the other hand, like just expecting, DigitalOcean Droplet to be running, Kubernetes or even K3s, it's a very tall order. And it's not only from a resource cost point of view, it's also from a application management point of view. Like if you're like a 20-person development shop, and one of the amazing things that GitLab's got at the moment is like apt get install GitLab is this incredible thing, and you kind of go and you do that and it runs, and then once a month you do apt get upgrade, and it, like I don't know if you've ever used it. It's phenomenally good. Like it just works. And obviously taking and those companies, they've got like maybe someone who kind of does that, but maybe not full time or whatever. And they don't want to operate a Kubernetes cluster.
No, that's wonderful. And
they just want their GitLab to work. And
of course,
so it's kind of like a tricky thing. And so we maybe will have to build some of that stuff ourselves, but obviously.
Because for the like larger, like, so like I come from a company where we've done microservices over a number of years now. And so I kind of know what the challenges are. And like typically you then converge to solutions that will introduce another like kind of management plane that will eventually, whether you write that yourself or whether you use something off the shelf, it will happen either way. And there's like new fancy solutions like service meshes, which we didn't use at SoundCloud, but that stuff exists. But it's kind of at odds exactly with what you mentioned, with the whole idea of having like this one-stop shop solution that scales to a different size of customers. And actually, like one idea that was floated, just very roughly, but like the term, I think GitLab Lite has been dropped before. So I actually wonder if like long-term, we will be able to deliver that to, cater to all these different kinds of customers, because it's such a large spectrum. So maybe at some point there will have to be something like a slimmed down version of GitLab, which specifically targets a certain class of device.
I looked into the problem that your whole team is looking at very briefly after about 2 summits ago, after the Cape Town summit, before I got dragged back into all the infrastructure stuff. Like Sid kind of challenged me to take a look at it. And, I was doing a lot of profiling around memory, and probably what you guys are doing. But obviously you're doing it in much more depth and with much more focus than I was. But I really did feel at the time that, the GitLab philosophy of building out this, integrating everything together and having, 20 different stages of development, it's always kind of going out sideways. And then at the same time, each of those stages is becoming more and more mature with more features. That's amazing, but it's also really hard to tie that back into, at the same time, having something that runs on a Raspberry Pi. And you can't like sort of have it all. You've got to choose. And I tend to agree with you. Like just loading all of that into memory and running that whole application. Like there has to be kind of points at which you can break it and say, well, this is like the small thing. So I don't know if it's possible to carry on. If you carry on at the rate at which we're developing features in 5 years' time, can you imagine how big the product's going to be? And are we still going to have the requirement to run all of that on the Raspberry Pi? And is that going to be physically possible?
It's an interesting challenge, and it's actually quite a unique challenge because, I mean, of course, there are a number of like quite substantial Rails monoliths that work at scale, on the web, but those are not meant to run on Raspberry Pis.
Exactly.
They run on. But okay, that's it's a really interesting discussion. I'm curious where that goes. Do you want to circle back to the
sure.
the Sidekiq cluster? story around the command arguments, because just to give you my perspective on it, so the immediate problem I was facing was that putting Sidekiq cluster in front of every developer via the GDK meant that we would have to specify these queue groupings from basically within a run script, right? That run it, for instance, would manage. And then the question was like, what is a sensible way to group this up? And so I thought maybe it would be easier, at least in the interim, to just provide the desired scale for the cluster, like just for a local development environment. Say you want to run 3 processes or whatever, and then like all worker processes would process all queues. So that's kind of what I did as a first step to just make it work, because it allowed me to kind of bypass that, and maybe also sidestep.
No, I think
friction with what you did.
I think that's totally fine. I would say that, I mean, just set it to 2. Like you don't need to make that configurable. Right, and exactly like what you say, just have all of them running all of the jobs. The only thing that's going to be a little bit kind of interesting is, obviously we're not doing any sort of pre-forking model here or anything like that, and so you're basically running like an extra Rails monolith, which is going to take up a little bit more memory for people.
Right.
What could be interesting is maybe consider putting in some documentation, like, if you're really kind of tight, or your machine, you're running on a MacBook, not MacBook Pro, this is how you set it down to one Sidekiq process, which will kind of be exactly the same as but
we might have to do that anyway. Sorry to interrupt, because I think we might have to do this anyway, because I really want to strictly separate this particular step, which is really just about dogfooding Sidekiq cluster to developers. Whether they be external or internal to GitLab. But I want to separate this very clearly from the rest of this overarching story, which was to move Sidekiq cluster into the core tier. I see this quite separate, but once we do that, we have to do what you mentioned anyway, because currently we do allow users to, so before we make that move, we have to do what you mentioned anyway, because we currently have the default mode in Omnibus is to run a single Sidekiq instance and clusters this whole separate thing, under the EE Starter Plus. So if we were to make this change, we would have to have a way of running Sidekiq cluster as a one process cluster anyway, at least in the interim.
And that kind of ties back into whatever you do with Sidekiq cluster being backwards compatible. So I guess if you move it from EE, I'm going to use the old terms because they just stick in my head. Move from EE to CE, commit that, get that in. Obviously make sure that all the Sidekiq cluster stuff continues to work, which I guess wouldn't be too challenging. But then, and then once that's in and people are using that, as a step later, and obviously the main thing is you make sure that Sidekiq continues to work as it did before, and then as a next step you make it that GDK starts using Sidekiq cluster, because of the source installs and because of Omnibus and everything else, we really want to make sure that the existing method overlaps with the move, right? And so that it'll really avoid a lot of complexity if those two things can overlap. So if you move it across, get that finished, and then everyone's carrying on using Sidekiq as a first step, and then after that move GDK to Sidekiq cluster, consider moving Omnibus. So what's the plan? Is Omnibus going to continue to use Sidekiq or Sidekiq cluster in the long term?
In the long term, it would use Sidekiq cluster, and the idea then would be maybe if there is an intermediate step, or actually even for ease of migration for customers because of the extra memory requirements that you already mentioned, we might want to run for core users, we might want to run a single process cluster, but it would go through the same script, right? It would just still start one worker. It's basically just a one extra level of indirection.
So just help me understand, what are the value adds? So in a one process cluster, is Sidekiq running inside the same process, or is it still being?
It is a separate process, so there would
it's
still
a separate
be
process. Okay.
Yeah, there would still be. So basically, you run it would spawn what's called the CLI component here, which is kind of a small like cluster supervisor in itself.
I've seen it. Yeah,
and that would then just spawn a single worker process. So it actually lives in a separate P group even. But the memory overhead of having that process in between is quite small. We actually looked at this both in production and in development setups, and it's I can't remember it off the top. It was something like 17 megabytes.
It's mainly because the CLI doesn't use bundler and
exactly,
and load all
it's fairly governance as far as
okay.
So there would be some small overhead that seems unnecessary, but I think it's a reasonable price to pay for just having like just one way of like starting Sidekiq workers.
Yeah, I mean the only thing it's not a concern, but you know, if we've got to consider, okay, well then do we want to use that for Kubernetes as well? Do we want to have something that boots Sidekiq cluster with a single, and then, you know, it's basically a wrapper script around Sidekiq.
I would say maybe in the maybe during the transitional phase, once that is done, we can still kind of, you know, condense this down and kind of cut out all the extra crap that we don't need. So one challenge, since we're talking about Kubernetes again, one challenge will be that we can't rely on Kubernetes for everything. Things like the memory supervisor that currently runs as a thread, which is something else I want to fix. That it would be in some kind of external entity instead. But just outside of that discussion, we will continue to have the need to monitor the memory that is being used by a process. And I'm not sure, like, especially if we say there will be a lot of customers that can't even run Kubernetes, there are certain things that we still need to exist and run and operate outside of Kubernetes. So that might still be separate anyway. And so the current proposal was, that's not like the final decision maybe, but I think the easiest thing would have been right now to fold all this stuff into Sidekiq cluster, this parent process, since that already does some sort of like worker supervision, you know, like killing them if one of them dies and other things like that. Yeah. So that we have it all centralized.
It would, I can highly recommend going and looking what Giddily Ruby does, because it really pains me that these are all discussions that this other Giddily team has done, and they're doing. I mean, the sad thing there is that theirs is all in Go. So I mean, it's going to be really hard, but it kind of swings back. And again, I'm not offering answers here, but you know, this is all stuff because Giddily Ruby has memory consumption issues as well, and so it kind of also, you know, like they're doing the same stuff and they kill the process, and so maybe having some sort of Giddily Ruby is just part of Giddily, so it's actually like a subdirectory.
Okay, so it's not a separate project. All right.
No, it's that one, and then there's a Ruby.
It's just a Ruby client, right? Oh, there you go.
No, it's actually a Ruby gRPC server. So what happened was all the Git code was all in the main application, and we started off by porting it to Go, and we realized that some of it is some of the oldest code in GitLab, and it kind of relies on bugs in the Git Ruby library, and just you know, not good test coverage, and we kind of realized the easiest thing to do would be to just take it and run it in Ruby on the Giddily servers, and so that's kind of why it runs as a Ruby service that's kind of encapsulated within the Go service, but then the Go service does all sorts of process supervision around it. And make sure that it's
interesting.
It does health checks on it, but it's just kind of like it's the exact same requirements, which is, you know, make sure that the memory is not going out, and if it is, you know, gracefully shut it down and replace it. It's exactly the same requirements, and so, you know, if we had a reasonable way of doing this outside of the CLI, I don't know. As I said, I'm not offering you answers, but go take a look at that in Microservices.
No, this is super helpful context. That's exactly the stuff that is useful for me right now, because I haven't been here long enough to really have this kind of broad overview, especially what has happened in the past. And so that's really helpful.
Cool.
All right.
Yeah.
Cool.
Awesome.
Yeah, but generally, I think as far as the syntax proposal, it makes perfect sense to me. Like, and I don't think, I mean, there is friction to the extent that I'm currently working on the same files, and I saw you send a POC MR already of how that could look like. But I still think that would be easy to integrate, because I didn't catch at all the logic that actually parses queue configuration from the command line.
And that's actually in Sidekiq config, which I think is already it's already in core, I think. It's not an EE module, weirdly. So so that wouldn't be moving, for example.
Yeah, I think actually it is.
Yeah. So I mean, that should be, I think it's a Sidekiq config. And that is, where is that?
Yeah, that's all right. It's just in libgitlab.
Yeah, so that would be, I mean, the one thing with my thing was that it doesn't, Sean pointed out that it relies on the bundler and loading all the classes, which it can't, because
there's some comments to that extent here.
It would actually be really good to have some sort of test to kind of enforce that, but it is what it is for the moment. Maybe that'll come in, but kind of my point here is that so like the history behind this was that we had a GitLab.com like SRE team, and they had basically taken all of the workers and divided them between these priority queues. And it was really complicated, because that work was done like a really long time ago. We're talking like 2-3 years ago, which in GitLab terms is like 7 dog years.
Yes.
And so like what had happened was, like, things had changed, and like half the things that were specified weren't really there anymore, or they weren't real queues. And what's more, like each priority queue, so we've got best effort, real time, ASAP, like no one really knew what those meant. They were just kind of like differentiation.
Just names, right?
Yeah, they were just names. And then some of them were running on 4-core machines that had like 12 threads per, and it was just everywhere. And so, and then each thread, each worker, so if there were 6 or 8 Sidekiq workers, they each ran, like each worker had its queues specified.
Right,
so
and they had a number of threads configured as well in some cases.
Yeah, and it was totally impossible to kind of, like if a queue started going up, right? Like I actually built an Excel spreadsheet model of the current situation, and it was basically like indeterminate. It wasn't, you could work it out, but it was like way beyond what any human could cognitively load into their head. And so if a particular queue was going up, right, it would start climbing and climbing, and it might be that, well, that's only assigned to this thread and this thread, but that thread is currently got a lot of this other work on it, and meanwhile, all the other processes on that host are just sitting there idle.
Right.
And so,
because they're assigned to different queues.
Yeah, they're all assigned to different queues. And like one of the things that we kind of changed with that was like, let's just make them all the same.
Yep.
And we've had way less outages since we've moved across.
That makes perfect sense. Yeah.
Because humans can actually understand it. It's like, we don't have enough compute for this set of jobs, like add more compute. Because obviously before, what you're doing is you're adding more compute, but only maybe one thread out of 40 was handling the job that was running out of control. So you were adding all these new computers or nodes, and they were just doing nothing mostly, except for the one thread that was still saturated. And so that was, and so kind of where we went with that was we cleaned it all up. But the problem is that it's still owned by the GitLab.com like SRE team, and they don't understand the jobs. It's the application teams understand what the jobs are. And so the whole thing about that syntax is the SRE team are like, give us jobs that are CPU bound and use a lot of memory and are latency sensitive.
Right, kind of have a contract between the developers.
Exactly. And then the developers are the ones who need to kind of say, well, this is latency sensitive, you need to run this for me real quick. Right. And so we kind of breaking that, as opposed to just, encouraging bit rot, which is what we
that's
had
great.
before.
Yeah.
And so that's where, so at the moment it's still done manually, kind of less manually, but it's still done manually. And what would be really great is if we could have that syntax so that it's just a contract between these two teams.
Yes. Yeah, excellent.
And we also, just one extra thing on that, we have that problem internally at GitLab, but we've got customers who have got even less ability to communicate with us who are also doing this. And I don't even want to imagine what their setups are like at the moment. So if they could just say, like put the latency sensitive jobs together and then monitor those in a different way from the non-latency sensitive jobs, that would make everyone's lives a lot easier.
Right. Yeah, I had one question that maybe you can help me understand it better, because why did I try to find it? Like, I think I might have asked it in the issue actually, but I'll ask it again. Oops, cable here. So I was wondering, so if I pass like a query or like several components of a query via the command line, then we select the queries that match, of course, the
workers. Yeah.
Yes, exactly, and spawn a number of workers per every match that we find, or how does it exactly map? Like what is the number like per node? How do I determine what the number of processes will be based on?
I think the proof of concept, I think I changed it. Originally, it basically fixed it to the number of, the concurrency was set to the number of, the number of processes was set to the number of cores. But actually I've rolled that back and I've just kept it the same as it is. But actually, basically it would be really nice if we could just have that as not as a number, but as like defaults to it almost defaults to the number of cores, because there's no cases where I found that having it like higher than the number of cores makes sense or low. It kind of matches to have the number of processes and the number of cores the same. The thing that is more complicated is to choose the concurrency of each process, the number of threads that are running. And so when we started off doing that 10x background stuff, the default I think was 50, which if you're thinking that, Ruby doesn't really do threading. And we kind of brought that down to so I did tuning. So basically in production, I would, set it higher, set it lower, kind of bisect the problem domain. And that's kind of where the idea of separating the CPU bound and the non-CPU bound jobs came from, because the CPU bound jobs, we found that having lower concurrency makes sense. And then for the non-CPU, kind of makes sense once you
with the
think
GIL,
about it.
I guess. Assuming a GIL.
I mean, if we could run some jobs in Gilly on the JV, in Ruby on the JVM, then that would be cool.
It's interesting. It's such a, I don't know if it's unique, but it's like, it's fairly, at least Ruby is the one major platform that I can think of where that is such a,
I think Python is the same. It's got almost the same.
Oh, I have very little experience with Python.
If you Google, and then obviously Node is something that I've had a lot of experience with in the past. Node kind of just takes it from a totally different angle, but for certain things, Node is obviously very powerful, because you sort of issue all these requests in parallel, sort of by default in the default programming model.
Because it's event driven, basically.
And so if you need to go to 10 backends, you just tend to do that in parallel. You don't go to the one and come back. And obviously in Ruby, it's very hard to do that fan and collect sort of approach. The very scary side of it is that unless people really know what they're doing, they might get an unbounded array of 10,000 items and basically push those off to a backend as 10,000 separate requests in parallel, right? So that it basically totally flattens your database server, because of the bounding on the parallel. Anyway, and then obviously the other side of it is, it sounds like you've got some Java experience. The problem there is that people can really kind of mess that up as well. So, you know, obviously, if
no,
they're
for sure,
experienced.
Yeah. Yes, definitely.
But yeah. It's interesting to look at this truffle. What's it called? Not truffle. What's the new Oracle Ruby JVM called again?
I'm not sure.
Truffle Ruby. It is Truffle Ruby. It's very so Oracle have built this thing called Graal. Obviously, it's Oracle, so it's Oracle. But Graal is this like generic VM, and they're building all these different language and obviously Oracle have got some pretty good experience building VMs. Like you've got to give them that, if nothing else.
There's an ex-SoundCloud person who's working on Graal VM actually.
Oh really?
Flavio.
Yeah, I mean it's an incredible project.
Yeah, he is amazing.
And but the thing with Graal is that they seem to be building, like, apparently Graal can run C extensions without too much hassle. Obviously, you can't do that on JVM. So that kind of makes it a really interesting proposal, and it is thread safe. Whether or not GitLab can actually run in a multi-threaded environment safely is like a whole other question.
Oh, of course.
Yeah. But yeah, it's interesting. I've been keeping an eye on Graal VM. It'll be really interesting at some point to start trying to run our unit tests on it and stuff. Because
yeah, very interesting. Okay.
Cool. Sorry, this is really veered off track. But so going back with does that kind of explain the concurrency?
Yep. Yeah, for sure.
So the main thing with the concurrency is that depending per workload, it's kind of fixed. So for things that are memory bound, we have a very low concurrency. For things that are CPU bound, we have a little bit higher. And then things that are IO bound, we push it up to about 10 or 12. So I think it was like 2, 5, and 10 or 15 maybe was the three sort of thresholds. But we don't need to kind of tune it any more than that at the moment.
All right.
Awesome.
Good. Very good. So yeah, as far as steps forward go, sorry, I need to double check actually if because this was this main story about moving Sidekiq cluster into core. I think we did move it to the next milestone anyway. So this is not happening anyway before next month.
Okay.
Because that required product approval and just took a while, and Sid had to green light it and everything. But this whole moving Sidekiq cluster in front of the GDK, there's actually an MR. So yeah,
but
it sounds like you're.
But do you not need to bring Sidekiq cluster to core before you do the GDK work?
No, interestingly enough, I don't, because fortunately enough, there is a wrapper script that's currently called by runit as employed by the GDK, which is bin/background jobs. So that kind of acted as a nice integration hook to just swap out the underlying call. So that's what I just I started by just doing a simple POC to see, does it even work, and then went from there, and it seems to be fine. So as far as the GDK goes, that seems to work well. An open question
so
is
GDK. So I don't know anything about this, but just to confirm, obviously, so GDK will now be relying on EE functionality. Are there any sort of concerns? And you're welcome to say no, but are there people that only develop against GitLab FOSS who use GDK? And is that
that's a very good question.
I don't know, but it's probably worth. I would probably go speak to Tone, or Jakob Vosma and check with that, because obviously it's just something to keep in mind. I don't know whether or not that's the case, but rather find out early and then.
You mentioned someone I could talk about this.
TOON, Belgian Tone. And the other person is Jakob Vosma.
Okay. Yeah.
He's just a very useful person who knows everything in the company. One of those people, and he's also very involved in GDK.
Great. No, that's an excellent point. I think actually, I think I might have already dragged Jacob in on this
Yeah.
MR. Yeah, he hasn't had a chance to look at it yet, but
yeah, he's all over. He's got a lot of
yeah. No, that's a really good point. I didn't even think
Yeah.
about that, so I'll have to look into that. Yeah.
And
So
there might well be, like, I don't know, sort of contributors who, insist on only using fast. So I don't know. I mean, I don't know what the vibe is there.
Yeah, no, this is exactly the kind of feedback I'm looking for right now anyway, because similarly to the from source installations, I hadn't even been really aware of that this is a thing.
Yeah.
And so it's good to talk to a lot of people right now. And
I mean, there's even people in the company, Shinya is someone I know, he doesn't run GDK for whatever reason. He runs like source install. And the other person is obviously you've got Camille has got his
Compose Kit. I use that.
Yeah, Compose Kit. Yeah,
I use
do.
Compose Kit. Yes, it's great.
Yeah.
I had so many problems with the GDK. I couldn't bother anymore to fix it every second day. I
really want to have this kind of halfway point where, because I use a Mac. So just a tiny bit of history. I came in through a company called Gitter, which was a company that
I know.
But anyway, we had a little thing that was all based on Compose, but we ran the main application server locally, and then we had all of the services in Compose.
Right.
And that did two things. The one was that we didn't have to deal with like the Mac file sharing issues and corruption between, editing a file on your Mac and then that change not being picked up in the, because obviously it's got to go through the HyperKit and then into the Docker machine, Docker container. And there's just so many places that it can break there as opposed to when you're using Linux.
It's also quite a fair bit slower. I used to use my previous
So I had this thing that I really liked, the fact that that your database was slowed down and your all your services were slow. They all had like a 10 millisecond round trip time,
right?
And that kind of really
it's more realistic.
Well, not only, but like if you've got an n+1 on some endpoint, and it's going backwards and forwards to your
you would
database,
actually notice it, right?
You kind of, and I quite like that.
That's interesting.
But anyway, so the kind of like I want to have Camille's Compose Kit, but I want to be running Ruby locally on my machine,
right?
Because I run a Mac, and so every now and again I get started on an MR, and then I just get
and the GCK is certainly not the end all be all, of these kind of development framework solutions, but and I have problems, but it has other problems, some like I think in terms of ergonomics it has some issues. I think especially like in my job, because we need to profile a lot. And that's the main reason I actually switched back to Linux. I wanted to be as close to what the customer runs as well, I guess. But like, if you have virtualization in between, that often makes it harder, to pull like memory profiles and whatnot.
It's interesting. I mean, so I know we're going off topic and we're well over time, but LabKit is a little sort of library that it kind of got a whole bunch of observability. I don't know do you know what LabKit is?
I've heard the term. I haven't used it.
Okay, it's kind of like so what happened was I was putting distributed tracing into all the different components of GitLab, and I was doing the same thing over and over and over, and obviously it makes sense to take that and put in the library. Right. So that was kind of the birth of this observability library, and kind of to some degree, I think like a platform library.
Is it a separate gem now, or where does it live?
There's a gem for Ruby, and there's a Go library as well.
Okay.
And they kind of got this similar functionality. The APIs are kind of suited to the language, it's not like the same API or anything like that. And the functionality kind of, it goes along a little bit lockstep. So it's not, it's not totally matching. Like one might have more of one thing. But anyway, the reason I'm mentioning that is because the Go Lab kits has now got profiling built in, built on Go pprof. And so basically it's kind of like one line that's like set up my monitoring at the start of your application. And that gives you your Prometheus scrape endpoints, but it also gives you all your debugging and profiling tools on that same endpoint.
Right.
It'd be really nice to, I keep it's something I like just need to kind of gather some time for, but have it that the Ruby version we move across to that too. So basically the Prometheus endpoint has also got like, give me a profile of the application, and it just kind of dumps something out. Probably help you guys a lot as well.
Oh, great. Yeah, that sounds really good. Good to know.
Cool.
All right.
Yeah, it'll come. But yeah, really good to, let me finish this recording.